This is for Year 10 General Maths. In exercise 5.3, we're going to look at finding angles using trigonometry. So if I have a right angle triangle, like we have in this case, we have two right angle triangles, we actually want to find what the angle value is equal to. Okay, so we can do this using SOHCAHTOA. Again, with trigonometry, we always identify our sides. So this is opposite the angle, this is obviously the hypotenuse, and this is the adjacent side. I can do the same for the second triangle. We know that C is the angle, opposite C is 1. The hypotenuse is obviously the longest side, and this 1.732 is obviously the adjacent side. Now, for the first triangle, let's figure out what relationship we want. Again, we start with SOHCAHTOA. Now, what do we know? We know the hypotenuse and we know the opposite. And the only ratio that uses opposites and hypotenuse is sine. See, opposite and hypotenuse. So let's formulate our relationship. Sine of the angle, we don't know what the angle is, it's just theta, equals opposite divided by adjacent. Now, I've got sine of theta equals, that's essentially a number, 14 divided by 20. How do I get the value of theta? We do something called inverse sine. So the inverse of sine undoes the sine of an angle. So what we do to one side, need to do to the other. So the inverse of sine undoes sine. So what essentially we get left over is theta equals inverse sine 14 divided by 20. And again, this is a calculate exercise. We can use our CAS to figure this out. Now, inverse sine is the sine symbol with the -1 next to it. So I press that. Again, I need to make sure I'm in degree mode, which I am, which is fine. Divided by 20 to get my angle. And my angle is 44.43 round to 2 decimal places. So theta equals 44.43 degrees round to 2 decimal places, and that's your answer. Now let's do another example. So we're trying to find C in this case, and what do we have? So I start with SOHCAHTOA. I have the adjacent side, and I have the opposite side. So adjacent and opposite is ruled by tan. We've got tan of the angle C equals 1, so it's the opposite, 1 divided by 1.732. Now, if we got tan of something, to get rid of the tan, we need to take the inverse of tan. So the inverse of tan C is just C. What we do to one side, we need to do to the other. 2. So the inverse of tan and tan undoes each other, so we just get C equals inverse tan -1 of 1.732. And all I do is enter that on the calculator. So I want to find the inverse tan. Now, if you don't have a CAS calculator, you can find the inverse function by usually clicking shift and your normal tan. So when you click shift and normal tan, it takes you to the inverse tan. So just you can tell whether you got the right tan by having the -1 on the top of it. So inverse tan of 1 divided by 1.732. Enter. so equals 30 degrees, 30.00 degrees, so it's just 30 degrees. C equals 30 degrees, round to 2 decimal. Well, there's no 2 decimal places, it's just 30 degrees. Now, if you don't know how to do it, there is another method you can use. So I'll go back to the first triangle. The original equation was sine of theta. So sine, instead of theta, I'll just put in x for convenience. Sine of x equals 14 divided by 20. And what I do is I can use the solve function. So I go interactive, advanced, solve for x. And I want a decimal answer. Okay, that doesn't work. We can't use solve. So you'll have to know how to use the inverse function for trigonometric functions.